Alright guys, so as we know, we are going to be learning how to write linear equalities in standard form based on word problems. So, as we know also, we're taking a trip to France as a class, so all of these word problems are going to be based on you guys. And our first victim is going to be Sage. So, Sage is saving money for a trip to France. She currently has $200 saved up. And she wants to save $50 every week until the trip. And now what we need to do, we're going to write a linear equation in standard form. To show how much money she'll have in X weeks. Okay, I know this looks like a lot. It is a lot. But we're going to chunk it. When I do word problems, I like to use two different strategies to kind of help me sort all of the facts. Otherwise, it is a lot to look at, and I know that I get overwhelmed, and it's okay if you guys get overwhelmed too. By the end of this, we're all going to know what we're doing, and so we're just going to take our time with it and chunk it as we go. All right, so my first duty while I look at this word problem is to take inventory of what is going on. So I see numbers. Sage has $200 saved. She wants to save $50 every week. And that's great, but I don't exactly know what I'm supposed to do with that information yet. So I'm going to keep reading. Write a linear equation in standard form to show how much money she'll have in X weeks. So my first order of business is I'm going to underline or circle important details so that I can gauge what I'm supposed to be doing with this word jumble. So the first thing I'm noticing is write a linear equation in standard form. So first I need to know what a linear equation is. And I know that a linear equation is an equation that can be graphed into a line. I also need to know that a linear equation can come in two different forms. It's asking me to do standard form, but it also has another form, and that is slope-intercept form. So to make my life a little easier, I'm going to make a little cheat sheet for myself up here of the formulas for both of those types of equations, so that once I'm solving, I don't have to worry about what I'm doing. If I'm getting the formula correct, I just have to worry about plugging everything in correctly. Okay. So slope-intercept, just a reminder, is y equals mx plus b. Standard is ax plus by equals c. So it's asking us to put it in standard form, but I like to put equations into slope-intercept form first. It helps us to make sure all of our values are still correct. You have to put it in slope-intercept before you move it into standard. So what I'm going to do now that I know what I'm supposed to do, I'm going to write a linear equation in standard form to show how much money Sage will have in X weeks. I'm going to circle or underline right here that it says X weeks, because just right off the bat, I'm seeing an X, which is a variable that also shows up in slope-intercept form. That may come in handy if it is going to be in the appropriate place. And so that's going to say the number of weeks. Interesting. So now I'm going to go through and go for my values and circle them so that I know what my values are before I even approach this. So I see Sage has $200 saved. I'm going to circle 200. I'm seeing that it's not multiplied by anything, it's not divided by anything. She's not sharing it. And so that's a fixed $200. It doesn't change. It just came as $200. It would leave as $200. It is always $200. It's not affected by anything else. She wants to save $50 every week. So this, I'm noticing, is dependent on how many weeks there are. And so I'm not going to just circle $50 because that would look like the way 200 shows up, where you just give 200. It's just 200. It's not dependent on how many weeks go by. It's always going to be the same 200. $50 is going to change every week. And so I'm going to circle $50 every week so that I'm aware that it is variable on how many weeks there are. This means it's going to be multiplied while I'm doing my equation. So like I said, I like to start with slope-intercept. That's how we are going to start. So I'm going to write over here y equals, that's all. So that I can get my slope-intercept running and getting ready with it. So next, I'm going to do So next, after I have y equals, I'm going to have to put mx. So this is going to show that m is multiplied by something. So I'm going to look at this real quick, at my word problem. I'm going to think, okay, is $200 multiplied by anything? No. Okay, she wants to save $50 every week. I know that this $50 is contingent on the amount of weeks that happen. And I also know that weeks was labeled as x right here. So weeks is x. So I could write x. And something's gonna go right here. So y equals mx. What gets affected by the weeks? The $50. So I'm gonna put the $50 here. Or just 50. You don't have to put dollars. I'm going to rewrite that because I made it look a little sloppy. 50x. And then I know that the only thing I have left is the plus b in slope-intercept. And so that's something that's not getting multiplied by anything. So what I'm going to do is I'm going to look through this one more time. Sage has $200 saved. That's our fixed rate right there. There's no other values in this word problem that are fixed or are getting multiplied because we've already done our $50 a week. So our only other value, or only other option is the $200 saved. So I'm going to say y equals 50x plus 200. Alright, so let's just check this really quickly before we move on. So our only two values are here. So Sage has $200. Check. She wants to save $50 per week, 50x. 50 per week, week is x. Check. So we have everything that we need in the problem. There's no other values in the problem to worry about. So it looks like it's done, but we still need to put it in standard form. And so we're just gonna do some simple subtraction like we do. So if you look up here, you can see that standard form. So A and B are in place of constants. The x and the y are as variables, which we already know. It's just a reminder. And then C is a constant. So the goal for a standard is to have anything with a variable on one side and then anything as just a constant on the other. So you're going to subtract 50x from both sides, because what I'm seeing here is we have a constant, we have x with its coefficient, and then we have y. So we have two variables and then a constant. So I want to have the two variables on the same side as one another. So subtract 50x from both sides. And now this can be written in two different ways. I like to write it as y minus 50x equals 200, because I just think it looks cleaner. There's one subtraction sign. But if you want, and you still have like the AX here, the BY here, because this coefficient would be 1. And then you have 200 as your constant. But your other thing that you could write it as long as you keep the operations correct, is if you do negative 50x plus y equals 200, because you still have your AX plus BY equals C. Now, the other method that we are going to use is a little more concrete. You will still end up with your standard form, but you're not doing as much reading in between the lines. You're drawing pictures. So what we're going to do is we're going to pick on Tony now. So Tony is booking his hotel room for his trip in France. His hotel room has a flat rate of $100. Flat rate of $100. And then, wow, that's not correct English at all. It also has an additional $25 per night. And then write this in standard form. Okay. So we're going to tackle this the same way as I did the first one. So what I'm going to do first is I'm going to look at it. I'm going to draw a grid over here. You'll see why in a moment. And so instead of circling everything, I circled stuff earlier. So now I want to write it on the side of the board. So I see the hotel room has a flat rate of $100. It also has an additional $25 every night. Write this in standard form. So the first thing I'm seeing is I have to write it in standard form like the first one. That is our objective of today. Excuse me. So then the hotel room has a flat rate of $100. I'm just gonna write this over on the side. I'm gonna color code it. You'll see why in a moment. But I'm gonna write flat rate, or just flat, because it's for me to remember. Flat is $100. And then in blue, nope, in red, I'm gonna write, it also has an additional $25 every night. Now this is the same thing as before. So with the $100, it straight up says it's a flat rate. So I don't need to worry about writing anything else. But now it also has an additional $25 every night. So that means it's not a flat rate of $25. It's going to be dependent or variable on however many nights Tony decides to stay in the hotel. So I'm going to write $25 every night, because if I were to just write 25 over here, I think it had the same meaning as 100, and it doesn't, because the 25 is repetitive, whereas the 100 is stagnant. It's staying just as 100. It's not becoming any greater or any less. So 25 every night. All right. So now we're going to draw pictures. I know that's what everyone wants to do right now. So we're going to label this. Also, just a quick thing. I'm going to say day 1, but day 1 includes the full 20 hours of like morning and night, okay? So I'm not actually going to label that because I think you guys will do that. So we're going to draw pictures as if we were illustrating this for one day, or one morning and one night. So I know that the cost of the hotel for one morning and one night would be the flat rate of $100, and I don't think, oh, I hope this doesn't affect it. Sorry, I got a call. So I know that the flat rate of the hotel is $100. I also know that it's the first day, so we're not having anything more than the $100 for the flat rate. The flat rate's not multiplying or anything. And then there's a $25 every night. So we're gonna add a $25 for day one as well. So we have the $100 and the $25, just because they're the same shape, they are of different value. So then, what I'm gonna do next, I'm gonna do day two, just so I could kind of get an idea of what I'm doing. So I have a flat rate of $100, so I'm gonna draw my $100 again. And then 25 every night. So if it's day two, I'm gonna do one night, and then I'm gonna do 2 nights. So then day three, I'm gonna do the same thing, flat rate of this, and then there's not gonna be an additional flat rate. The flat rate stays the same, like I said, it's stagnant. But then I'm gonna see that the $25 every night is day one, day two, day three. And then let's just skip day four. I'm gonna do day five, just so I could kind of see like a little bit more of time go by. So it's a flat rate of $100. I'm not gonna add any more than that $100 because that flat rate just stays the same. It doesn't get multiplied or anything at all. And I'm going to add the 5 nights for the red. So 1, 2, 3, 4, 5. And now the reason that I made these boxes and not tally marks, you could do whatever you need. But even though I'm drawing these right now, you could use this with anything. These could be your flat rates, and the markers could be your variable of 25 every night. So you could use whatever manipulatives you have, which is why I like this strategy if you ever get stuck on a problem. So now that we've drawn out and kind of got an idea of just how this works, we're going to write this in standard form. But like I said earlier, I need to start with slope-intercept form. So I'm going to start with my y equals. It's an easy spot to start at. Can't really get it wrong. So y equals. So then I'm going to do my mx. And I have to see, mx means that it is being multiplied. It is being affected. So I'm going to come over here, and which thing is getting affected? The blue or the red? And I'm going to notice, well, the blue stays the same no matter how many days go by, but the red always changes depending on how many days there have been. So $25 every night is the thing that is getting multiplied by however many nights there are. So I'm going to say y equals 25x, because my x is nights, we can see in this problem. And then the last thing I need is my y-intercept or my plus b. And so what I'm going to do is I'm going to look through the problem again. Flat rate of $100. I'm going to look at my picture. Did anything change with my blue? No. So it's not getting multiplied by anything. It's stagnant, like I said. It's not changing. And so I'm going to put plus $100. But once again, you guessed it, we're not done. So we have our slope-intercept, but we still need to change it to standard form. So what we're going to do is we're going to subtract our 25x from both sides, because once again, for standard form, you want the variables on one side and then the constants on the other. So minus 25x minus 25x. Well, I guess it doesn't cancel out. And then Once again, you could write it in either way you want. If you want the standard ax plus by, the traditional version where you have your a and then your x, you will do, wow, your a and then your x, your a and then your b, or your x and then your y. You're going to do minus 25x plus y equals 100, or you can do y minus 25x equals 100. I will take them either way as long as these signs are correct. Technically this y is positive. All right. Let's move to we do.